All right, so this is lesson 612. Yesterday in class we learned about a thing called the Pythagorean theorem, which says that the area of the square on the hypotenuse of a right triangle is equal to the sum of the areas of the squares on the legs. And we summarized it using this equation right here, a squared plus b squared equals c squared. So a and b are the legs of the right triangle, and C is the hypotenuse. Today we're going to learn how to apply that theorem, use it to solve some problems. So here's our first problem we're going to take a look at. So here we have a tile, and what we're wondering here is, these are all square tiles, 6 inches on each side. We want to know what the length of the hypotenuse is. In other words, if we cut one of those tiles in half along the diagonal, how long would that diagonal be? Okay, and here's your example, how you can do that. What we have a squared plus b squared equals c squared, and so 6 inches is a leg, are the two legs, they're both 6, so 6 was substituted in for a and b, and then that's simplified, added together, that's 72. And so the area of the square and the hypotenuse, c squared, is equal to 72. Then to find the length of c, we want to know what the principal square root of that is. Actually, this equation has two answers, a positive and a negative answer, but we only want the positive one since we're talking about a real length of a tile here. And so we're going to take the square root of 72 to find that, and that's about 8.5. So this length is about 8.5 inches. Not exactly, but pretty close to that. You can check it on your calculator by doing the square root of 72. Okay, so here's the problem we're going to do. It says, what is the length of the hypotenuse of a right triangle with legs of lengths 9 and 12? I should caution you that this only works when you have a right triangle. It doesn't work for any triangle. Like I couldn't say this on this obtuse triangle. I cannot say that a squared plus b squared is equal to c squared. In fact, I could say it's not equal to c squared. Only if we have a right angle. Okay, so here's the problem. What is the length of the hypotenuse of a right triangle with legs of lengths 9 and 12? So the legs are 9 and 12. The legs are the two parts that make up the right angle. And I'm going to assume that the shorter one is the 9 and the longer one is the 12. So I'm going to put that in there. And then the other one we're going to call C, the hypotenuse we usually label with C. So we need to remember this formula, a squared plus b squared equals c squared. That's the Pythagorean theorem. And now we can substitute, since I have both legs, a and b, I can substitute those values in there. So I get 9 squared there, 12 squared there. 9 squared is 81, 12 squared is 144, so I simplified that. I can now add those two together. 81 plus 144 is 225. That's equal to c squared, the area of the square and the hypotenuse. Now I'm going to find the principal square root of that, which means the positive square root. To get c, when you take the square root of an equation that's a squared equation, that undoes that square. Then I'm going to simplify that. The square root of 225 is 15. So the length of the hypotenuse is 15. All right, so that's how you do a problem where you're given the legs. Sometimes you're given some different information. Like in this case, you are given this information. One of the legs is 5, the hypotenuse is 13, and the other leg we do not know. We want to know what that is. Notice that we're using the same formula, the Pythagorean theorem, a squared plus b squared equals c squared. We're substituting 5 in for a and 13 in for c, which sets up a little bit different for our equation. So then we get 25 plus b squared. 5 squared is 25. 13 squared is 169 by simplifying. Then we can subtract 25 from both sides, and we get b squared equals 144. Then find the principal square root of 144 to find b, and that's 12. So the side length is 12. All right, so let's try one here. Here's our triangle. We're given the hypotenuse, so we're given c. We're given b, and we're looking for a. All right, so let's try that. You could try it if you want. In fact, go back to that page and just try to figure that out on your own. Use your calculator. See what you get, and then we can turn the page and see if you're right. All right, so here's our triangle, here's our Pythagorean theorem. We're just going to write the steps in here. All the work is done. We're just going to write what we're doing. So that's the Pythagorean theorem. Now we're going to substitute a value for B and for C. B being one of the legs, C being the hypotenuse. Okay, then we're going to simplify the squareds. And that gives us 144 and 225. Then we're going to subtract 144 from both sides. That's called the subtraction property of equality. And then we're going to take the square root of both sides and the positive square root. And then we're just going to simplify that square root to get the answer. All right, so that's how it works. All right, so here's another property that we can use Pythagorean's theorem to help us with. If a triangle has side lengths of A, B, and C, and A squared plus B squared equals C squared, then the triangle's a right triangle. So what we're saying is, if we have any three numbers, like let's say I have a number 2, then I have a 4, and I'm just going to make this up a 5. If we have a triangle with those lengths, and 2 squared plus 4 squared is equal to 5 squared, if that's true, so I'm just going to put a question mark there because I'm not sure it is, then we have a right triangle. And so I'm just going to check here, 2 squared is 4, 4 squared is 16, 4 plus 16 is not equal to 25. So 2, 4, and 5 would not make a right triangle, because it's not true. But let's check this out. How about 12, 16, and 20? Let's try that. So if 12 squared plus 16 squared is equal to 20 squared, then we have a right triangle. And 12 squared is 144. 144. I'm just going to put my work up here. So 12 squared, 144. 16 squared is 256. If those two add up to 20 squared, I'll do that in green, then I got a right triangle. And 20 squared is 400. So we want to see if this is true. Put a question mark. 144 plus 256 is equal to 400. So we're going to say it is a right triangle because that is equal to that. All right, how about this one? And you can pause at any time, try it on your own. Why don't you pause right now and do your own work. See if you think 9, 11, and 14 makes a right triangle. It will make a right triangle if 9 squared plus, sorry about the phone. So plus 11 squared is equal, if that's equal, with a question mark, 14 squared, then we have a right triangle. So 9 squared is 81, 11 squared is 121. Is that equal to 14 squared, which is 196? 81 plus 121 is 202, not 196. So it is not going to make a right triangle because this is not equal. All right? So I'm going to let you go ahead and try it here. If I were you, I'd pause, use your calculator, and see if these each make right triangles. If 5 squared plus 8 squared equals 10 squared, then it is. Check it out. True or not? I'm going to say no on that one. All right, the second one, B. We want 9 squared plus 40 squared to equal 41 squared if it's a right triangle. Question mark. 81 plus 1600. Is that equal to, let's see, 41 squared? I'm going to use one of my little tricks to do this. 40 plus 1 squared, that's 40 squared plus 2 times 40 plus 1 is 81, which is 1681. Is 81 plus 1600 equal to 1681? Yes, it is. So that's a yes. All right. You can go ahead and do the other two. I think you know how to do it now. All right, identifying right triangles. Could the lengths 20, 47, and 52 be the side lengths of a right triangle? And first of all, you have to make sure you're setting this up right, where you have the lengths in the right places. Obviously, 20 and 47 are going to be the two shorter sides. 52 is going to be the long side, which is the hypotenuse. And the only one that gives us that is this one. So then we want to check this equation. Is 20 squared plus 47 squared equal to 52 squared? And 20 squared is 400. 47 squared is 2209. And 52 squared is 2,704. So are these equal? Let's just add 400 here, and then we get 2609. So we're going to say, no, they're not equal. So equation is false, not a right triangle. All right. Error analysis. Student found the length x in the triangle at right by solving 12 squared plus 13 squared equals x squared. Describing. Correct the error. All right. Circle the equation that correctly relates these. Remember, we have a squared plus b squared equals c squared. C is the longest side, so that's up there. B can be either one, and A is here. So we need like 12 for B or A, and then X in these two spots. So that would be that one there. And the student used 12 and 13 as the A and B, the legs. So we'll just say that used the numbers and number for the wrong part of the triangle. All right, so we want to find it the correct way. We're going to do this. 12 squared plus x squared equals 13 squared. Simplify these squares, and we get 144 plus x squared equals 169. Now we're going to subtract 144 from both sides, and then we get x squared equals 25. And we want the principal square root, in other words, the positive square root, and that would be 5. So x is 5. All right, that's it for the lesson. I'll see you in class tomorrow. We'll practice some more Pythagorean theorem.